Okay. Today we're going to be looking at the binomial series and writing it in different ways. Let's get started here. This is normally the way you see you'll see binomial series written out. This is here. This is s plus r, the quantity to the n, is s to the n. S to the n minus 1, s to the n minus 2, until you get to s to the 0, right there. It would be s to the 0. And notice that the r goes r to the 1, r to the 2. Of course, this was r to the 0, and r will go up to, just like it started with s sub n right here, it will end with r to the n over here. So this is what you normally see written in mathematics books for the binomial series. Of course, we will have to have this here. Notice this is n. Then it's n times n minus 1. Next will be n times n minus 1 times n minus 2, and so on. And here we'll have 2 factorial here. This will match the power of the n, of the r right here. So notice here it was power of r was 1, so this was 1 factorial. We neglected to write that in because, of course, 1 factorial is 1, but there is a 1 factorial right here, and over here there'll be a 0 factorial, which is also 1, so we don't really have to write that. So notice that this will factorial will be the same as the power on the r, so of course over here you would have over n factorial as the last term, if you will. Okay, so I didn't want to go much into this because this is the normal way that we see binomial series written out. I wanted to introduce new ways to write out the binomial series. So let's take a look at a little bit different way to write the binomial series. Here's the exact same series. And this time we'll set it equal to this definition right here. Let's see if this will generate our normal definition of binomial series that we find in mathematical reference books. So notice that if j equals 1, we'll stick a 1 in there. We'll get s to the n minus 1, and lo and behold, that is this term right here. If j equals 1, we'll get r to the 1, and that is that person right there. And if j equals 1, we'll get a 1 right here. K will go from 1 to 1, which means just k will equal 1. We'll stick a 1 in here. And negative 1 plus a positive 1 is 0. And we'll get n, which is that person right there. And if j equals 1, we'll get 1 factorial, which is this right here. So for j equals 1, we do generate this term right here. If you ask about this term right here, of course, it's given right here. We had to pull that out for index reasons here. It was easier to just pull this term out here. Okay. And if you, if you let j equal 2, you will find, you will get this term. By the way, this is the product function right here. It is not a sum function. Product means you multiply. So when j equals 2, you'll have k equals 1 first of all. That will give you the n right there. But on the second one, the k will equal 2 when j equals 2 here. And so if you stick a 2 in here, negative 2 plus 1 is a negative 1, so you get n minus 1, which is this person, and then pi multiplies these. So the first one was n, and pi multiplies as opposed to the sum adds things up here. So this is a new way to write the binomial series in a programmable fashion. You can program a computer, calculator, advanced calculator to generate the binomial series for certain quantities. Let's try to find another way to rewrite this, and that would be this method right here, we still have this is the same, and the S sub n is the same. This is the same also, and the Rj is the same. The only thing that's changed is this product function has turned into an exponential of a series right here. So this is e to this series right here. And you might say, how do we convert a product into an exponential sum of the logarithm of actually the exact same term? If you see this, this term, n minus k plus 1, is right here. And we can convert any product into this quantity right here. And I'll show you how to do that down here. And it'll prove that all three of these are three different ways of writing the binomial series. This one will have a product function. If your calculator doesn't have or whatever computer program doesn't have pi, or it's more difficult, you can still use a sum. So now this will have all sums in these in this series. So let's see how to convert a product into a sum, in case you don't know that. A product is 1 times 2 times 3, of course, all the way to the n. We write that as k goes from 1 to n of a sub k, whatever the term is. This one is just going to be, in this example, if it's 1, 2, 3, then this would just be k. You know, if it was 1 squared, 2 squared, 3 squared, the a sub k would be k squared, you know, and so on. So this is the function of whatever product you have. So this is how you write a product right here. What we notice here is if we take the natural log of this, we'll get the natural log of the product. The natural log of this, of course, things that are multiplied when you take the natural log become a series of natural logs. So it'll be the natural log of 1 plus the natural log of 2 and so on. This is a property of natural logs. I assume you know that. So notice that the natural log of p will equal natural log of 1 plus natural log of 2 plus natural log of 3 all the way to natural log of n. Well, that's the same as saying k will equal 1 to n. This can be written as a series, a sum, of the natural log of a to the k. So if it's 1, 2, 3, then a to the k will just be k. If it's 1 squared, 2 squared, 3 squared, a sub k will be k squared. If it's 1 cubed and so on, then it'll be k cubed. So a sub k is the function of the numbers that are in here there. So we see that the natural log of p can be written as a series. So p equals the product. So the product we can stuff right into there. And I did that over here. Natural log of p, the natural log of p equals the product function right there. So this stuff is this guy right here. And that equals, this guy equals this guy right here. So I just put that is equal to that right there. So this went here, and that went here. So these two are equal right here. And finally, we can solve for the product function right here. How do we solve for the product function? Well, we'll have to get rid of the natural log. And of course, we'll take e to this side and e to that side. So e to the natural log is just simply the product function. And e to the series is e to the series. So a product function right here can be written as a series, an exponential series right here. So e to a series is equal to the product function. And that's all I did here is if I have a product function of some function, here's the product of some function, that equals e, there's the e, to the series, k equals 1 to n. I have 1 to j because of my index is j, of the natural log of n minus k plus 1, which is the natural log, and the function here of the product, whatever's in the product right here, a sub k, is this function right here. And so that goes right in front of the natural log right there. And so that needs to go there. So that's why this is the exact same binomial series as this right here. Okay, I hope you enjoyed this video, and I look forward to any comments at the bottom. Thank you very much.